Now that we have our current, we can now calculate the potentials across each of the different components. So for the resistor, voltage across R1, that's just going to be equal to my total current times the resistance. Now I can do this in phasor form because it's just multiplying by a value. So I can have 1000 ohms times 5.148 times 10 to the minus fourth amps at an angle of negative 43.282 degrees. And since it's just 1000 multiplying this, it's just a scalar, then all I'm going to have is 0.515 volts at an angle of negative 43.282 degrees. For the capacitance, I'm going to have the total current times the capacitive reactance, not just the capacitor, the capacitive reactance. And so that gives me 5.148 times 10 to the minus fourth amps at an angle of negative 43.282 degrees times my capacitive reactance, which was back here at negative 0.707 J ohms, and I can convert this phasor and that's in amps. I'm going to have to go down the line below it. So this is in amps, and then I'm going to have negative 0.707 J ohms. I want to remember this is in amps. And that gives me negative 2.496 times 10 to the minus fourth minus 2.651 times 10 to the minus fourth and that's going to be times J, and all of this is a potential or voltage, and if I convert that to phasor, I'm going to get 3.641 times 10 to the minus fourth volts at an angle of negative 133.282 degrees. For my potential across the inductor, it's going to be IT times my inductive reactance and my inductive reactance was 942.478 J ohms. And that, break this out again like we did before. Times, now we have the 942.478 J ohms, and that gives us a result of 0.333 plus 0.353 J volts. And if I convert that into polar, I get 0.485 volts at an angle of 46.718 degrees. So this is our potentials across each of our components, and you notice that everything is at different angles, and these angles are 90 degrees apart. So this angle for the capacitance is minus 90 degrees from the angle for the resistance, and the angle for the inductor is 90 degrees plus this angle for the resistance. So it comes in 90-degree pairs when you look at the resistance and the inductance. This applies for the series circuit. It'll also apply for the parallel circuit. Once we get into more difficult circuits, this may not be true.